Welcome to Wi-Fi Hacking V3 from Hacker's Rise. As you know, I'm OTW, and okay, David says, but your sound is horrible. Well, I'm sorry about that. Um, let's see. I wonder what we can do about that. Hang on one sec and see if I can change it. Okay, so this is Wi-Fi Hacking V3 from Hacker's Rise again. Um, We've had two previous versions of Wi-Fi hacking, and this is a new and improved course. We're going to add some additional tools, some additional content um, to give you a broader perspective on Wi-Fi hacking. And so with that having been said, let's get started. Okay, so what we're going to do first, here's kind of the outline of the course. And what I'd like to do today is to take a significant amount of time and focus today's class on the basics. So kind of an introduction to Wi-Fi and Wi-Fi hacking. So we'll be covering introduction, Wi-Fi basics, Wi-Fi frames, and Wi-Fi scanner. And then we'll leave some of these attacks to tomorrow's class. And then we'll look at these other attacks and other tools in Thursday's class. So classes will run probably somewhere around 3 hours or so, maybe four, depending upon how long it takes. Um, so by your time, we should be done by 6 p.m. UTC, 7 p.m. max UTC each day. So it'll be about a 3 hour to 4 hour class each day. All right. So, and today is going to be focused primarily on the basics of Wi-Fi. So everybody has a basic understanding of Wi-Fi. By the way, let's go. I'm going to skip out of here, and I'm going to go to my Kali, and here's my Kali, and we're going to open up a terminal. All right, and you can't hear me now. You can't hear me. Okay. Let me check my audio. Now it's fine. Okay, there might be a little bit of lag there, David. All right, and look, it might be on your end because I usually, if there's problems on the network connection, I get a GoToMeeting gives me a indication that says that there's a problem, and I'm not getting any. I'm getting a good, strong connection. All right. So, anyways, we're on Kali. This is Kali 2020. You can basically run whatever Kali you want. I'm using Oracle's VirtualBox. Okay. I'm also using an alpha adapter, a USB external alpha adapter. One of the things that people who are new to Wi-Fi hacking don't recognize is that the Wi-Fi adapter that's built into your laptop or into your desktop, whatever it happens to be, generally is inadequate for doing Wi-Fi hacking. Okay, so to do this well, you're going to need to go out and buy what's called an aircraft compatible Wi-Fi adapter. If you go to aircraft.com, you'll see that they have a list there, and mostly it's by the chipset. What I would recommend is simply go and purchase an alpha based. The alpha is the brand, and they all work really well with. You got an alpha, good, David. That's what I'll be using as well as an alpha. If you're using an external adapter, you want to go devices and go USB, and then click on the external adapter and make sure that it's connected to your virtual machine. If you're using a physical machine, there's no problem then. If you're using a virtual machine, you're going to need to use an external adapter, in part because the Wi-Fi adapter on your laptop or machine is piped into your virtual machine as ETH0. okay, as an Ethernet connection. So even if you have a Wi-Fi adapter on your physical machine, okay, that's capable of doing Wi-Fi hacking, you're still going to need an external adapter in using a virtual machine. So let's start off by simply going sudo ifconfig and give Kali its, and you can see that I have, this is actually a Wi-Fi connection that's then piped through my virtual machine as ETH0. I have a second Ethernet adapter as well. I have my loopback adapter, and then you can see I have my WLAN 0. If you're not using a Debian-based Linux, you might have a different name. And even if you are using a Debian-based, you might see WLAN 1, WLAN 2, WLAN 3 for your external adapter. Okay, generally it's going to come up as WLAN 0. All right, so if you have all of that, you're in good shape for this class. All right, let's go back to our presentation then. So this is what I'll be using. All right, I have almost identical to this one right here. You can use many others. There's a lot of them on there. If you go to aircrack.com, I'll pull it up on the screen for you. Give me a second here. Yeah, I gotta spell it right to get it. I don't know why I always spell aircrack incorrectly. All right, I'm gonna put this up on the screen for you. This is aircrack NG, and aircrack NG is the software for doing Wi-Fi cracking. There's a lot of other tools, and we'll use some of them in class. But basically, what these guys have done is built the command line based cracking tools. They've been around for quite a while, and almost no matter what tool you're using, it's usually got aircrack NG underneath it. All right. So, like in class, we'll be using Wi-Fi, for instance, and Wi-Fi uses aircrack underneath its GUI. There's other attacks like the PMKID attack that do not use aircrack, but that's more unusual. That's a whole different type of attack. Also, notice on this web page, you should see compatibility right here. Okay. And if you're seeing if your adapter, okay, will work, you can go here, and it's a little easier to understand than it used to be. Okay. So there are two manufacturers involved with wireless cards. The first is the brand of the card itself. Examples of card manufacturers are Netgear, Ubiquiti, Linksys, Intel, D-Link. There are many, many manufacturers beyond the examples we give. Okay. The second manufacturer is the chipset, such as Raylink, Atheros, Qualcomm. All right. So they use as an example here the Alpha AWS, and this is what I'll be using here. Okay. AWS 036AC. It tells you how to figure out, okay, what whether or not your card's going to work. If you go ahead and just get the alpha, you know it's going to work. All right. So I've been using them for years. I find them to be. I've tried many others. Some of them work better than others. The beauty of the alpha is it's relatively inexpensive and it works. All right. So there's others out there. You can get it without this is with the high gain antenna. There's other even better antennas than this, but this antenna works pretty well in terms of picking up a lot of the weaker signals around you. we talk a little bit about antennas, it's possible that you can have a number of different types of high gain antennas that can pick up signals from vast distances. Okay, but usually they have to be pointed at the Wi-Fi AP. And this is kind of a unidirectional. Okay, let's talk about some terminology before we go further. All right, the AP. You'll hear me talk about AP. The AP is the access point, or the place where the clients connect to the Wi-Fi and get internet access. Okay, you're probably using one right now in your home, in your office. All right. We'll often talk about PSK, the pre-shared key. This is the password used to authenticate to the AP. All right. Now, the reason it's not referred to as a password is that it's a password that everybody uses, okay, who connects it. There's not separate passwords for each individual. That's one of the weaknesses of the pre-shared key system, is everybody uses the same key. Now, we don't do that on our computers, right? If you're connecting to your network server, everybody uses a different password. Unfortunately, in most Wi-Fi systems, or maybe fortunately, people all use the same key. Unfortunate for their security, fortunate for those who are trying to hack it. All right. Then the SSID, that's a name used to identify the AP. Okay. So whatever yours happens to be, your name, Netgear, Linksys, that's the SSID. All right. The ESSID is the extended service set identifier. Same as the SSID, but can be used on multiple APs and wireless LAN. So that, for instance, if I have multiple APs in my office or in my school, in my business, then I can give them all the same name, all right? And that would be the extended SSID. For our purposes, for hacking, the most important thing is the BSSID, the basic service set identifier. This is the unique identifier for every AP. It's the same as the MAC address of the AP. We know what a MAC address is, right? It's a globally unique network adapter identifier, right? So when we're talking about the BSSID, we're talking about a globally unique identifier on that AP. SSIDs and ESSIDs are not globally unique. Anybody can name their AP any name they want, right? But the BSSID is globally unique. Channels, Wi-Fi operates on channels 1 through 14, but it's limited to 1 through 11 in the US. Now, depending upon what country you're in, yours may be different. Most of the APs, all of the APs and the Wi-Fi adapters in the US are limited to 1 through 11 by law, right? But in other countries, there's 12, 13, and 14 that are also available. This can be an important way of obscuring, say, a rogue access point. Okay, say in your country, say that you're limited to channels 1 through 11, right? And you set up your AP to operate on channel 13. Now, the administrators are not going to see that channel 13. We'll talk more about when we get into rogue access points. More terminology, power. Okay, the closer you are to the AP, the stronger the signal. Okay, that makes sense, right? The signal in the US is limited to half a watt by the FCC. And once again, depending on what country you're in, it may be more or less than this. Generally, it's going to be about a half a watt. Okay. Now, that's what the US limits, and your country may limit as well to half a watt. As a hacker, you're not limited to that. Okay, that may be an advantage that you can use against the system. So, for instance, if you were to turn this up to, say, 2 watts, all right, on your system, By increasing the power to 2 watts, you're going to be the strongest signal around. Your AP will be. Now, that can be really useful in, say, in an evil twin attack. An evil twin attack is where we have essentially we set up an AP with exactly the same SSID as a legitimate one and try to get people to connect to it. All right. And we'll set that up in class as well. Modes, this is important as we start off the class. Modes, Wi-Fi can operate in 3 modes: master, managed, and monitor. APs operate in master mode. Okay, wireless network interfaces operate in monitor mode by default, and hackers usually operate in monitor mode. Okay, this is actually a typo here. It should be in managed mode. Network interfaces operate in managed mode, and then hackers usually operate in monitor mode. If you're familiar with promiscuous mode, okay, promiscuous mode in your wired network, promiscuous mode means that you can see and listen in on all the traffic on the network. That's promiscuous mode. So normally your Wi-Fi adapter only will pick up the traffic that's intended for it. Okay, only for that IP, that MAC address. All right. But if you put your Wi-Fi adapter into promiscuous mode, then you can see all of the traffic going past you and sniff it and examine it. The same thing applies to Wi-Fi traffic as well. Wi-Fi, notice that there's Wi-Fi traffic going around us all the time, right? So sitting in your office, sitting in your classroom, sitting in your home, there's constantly this traffic going past you, right? You can't see it, of course, but it's passing you all the time. If you put your card, your Wi-Fi card, into monitor mode, now you can see all of that traffic. Okay, you can see everybody's traffic passing you by. Now, it might be encrypted. Okay, it probably is encrypted, but you can still see it. All right. The range, okay, at the legal limit of a half a watt, and that's the legal limit. Most Wi-Fi APs are accessible up to 300 feet or about 100 meters, but with a high gain antenna can be accessible up to 20 miles. So we've seen experiments done where with big parabolic antennas that we can actually pick up Wi-Fi signals up to 20 miles, but that's a very unusual case. Right? Using a Yagi antenna, those are those directional antennas, we can expect to pick up signals from a mile or 2. Okay, so that's what about about 3 kilometers. Okay, so anywhere from like 1 to 3 kilometers, 1 to 2 miles. Frequency, okay, Wi-Fi is designed to operate at 2.4 gigahertz. Most modern systems now use both. Okay, so the original specification, the early systems, all worked at 2.4 gigahertz. 2.4 gigahertz works great. One of the beauties of 2.4 gigahertz is that it can pass objects really well. Okay, it can pass through walls and objects, but it's relatively slow. 5 gigahertz can carry higher speed transmissions, but it can't pass through objects. It gets blocked by windows and walls and other objects in the way. So the ideal solution is to simply combine them, right? And that's what most of our modern systems do, is they use both the 2.4 gigahertz and the 5 gigahertz and get the best of both worlds, passing through walls and speed. All right. Security protocols. All right, once again, just kind of laying out the foundations here. WEP, or was known as Wired Equivalent Privacy. This was the original, okay? This is the initial security protocol to secure 802.11. 802.11 is basically the IEEE designation for Wi-Fi. IEEE is the body that goes ahead and sets up all the standards for radio transmissions. Okay, so it's called 802.11. You know that's the same thing as Wi-Fi. Was named WEP, or Wired Equivalent Privacy, by 2001. Hackers discovered that through statistical techniques, okay, that's important, statistical techniques, they could crack the user's passwords in minutes due to improperly implemented RC4 encryption. Okay, if you know your encryption, RC4 is a streaming cipher. There's nothing wrong with RC4. It was the implementation of RC4 that was done improperly. Okay, so there's nothing wrong with RC4. The problems with WEP have nothing to do with RC4. RC4 still works. It's still used in a number of other areas like VoIP because it's a streaming cipher. Most ciphers, okay, are block ciphers. So they take a block of data and encrypt it and send it along, okay? But RC4 takes every bit or byte and encrypts it and sends it along. That makes for smoother, like we're probably using RC4 right now for my voice, right? RC4, this is a VoIP transmission, a voice over IP transmission. And if I were using a block, it would be very choppy. It might be choppy anyways, right? But that's more has to do with the network connection, okay? But RC4, because it's encrypting every byte, therefore it gives you a transmission that is smoother and less choppy in voice communication. So that's what was being used initially. Nothing wrong with RC4. It was the way it was implemented. The IEEE had to quickly find a replacement as fast as all the Wi-Fi APs were left without security at that point. Few of these access points are still in use today. I still see occasionally one around. Okay, David says it's not choppy at all anymore. That's good. All right. So both our network connection and our RC4 are working well. So, anyways, so this is 2001. What's that? 20 years ago now, right? So we first got wireless in the late 90s, 96, 97. It first started coming out, and almost immediately it was determined that it was insecure. All right. So the IEEE had to come up with a patch essentially very quickly. Okay. So in 2003, IEEE created a short-term fix that they called Wi-Fi protected access. Okay. The key part of this new security protocol was that it did not require replacing the existing hardware. So that was one of the keys, is that they didn't want to have to replace everybody's hardware, because if they did that people wouldn't do it. They've already invested whatever they have, $100 or $50 into a Wi-Fi access point. If they created a new protocol that required that everybody replace their access points, it wasn't going to happen, right? And so what they did is that they tried to come up with a solution that made these systems more secure without having to change the hardware, right? And so what they did is they came up with basically a firmware update. And basically what it did is it also relied upon RC4, so it didn't change the encryption, okay, but added some additional features, making the pre-shared key more difficult and time-consuming to crack, okay? One of the limitations of the first APs is that they had chips in them that were relatively weak, right? So we couldn't put in, a stronger encryption algorithm, but we could put features into the encryption that made it more difficult to crack, more time consuming. These features included making the IV, the initialization vector, longer from 48 to 128 bits. So over here in WEP, our initialization vector was only 48 bits, very small, okay? So they increased it to 128 bits, okay? They ended up putting in the temporal key initialization protocol, which generates different keys for each client, okay? So basically each client is going to be slightly different. And it has a message integrity check to make certain the messages have not been altered en route. So basically it eliminates the possibility or makes it more difficult to do a man-in-the-middle attack. Then we ended up with WPA2, which is what most people are using today. All right, the WPA2 802.11i standard was initialized in June of 2004. So it's been around now, some 17 years. WPA2 uses the counter mode with cipher block chaining message authentication protocol, which requires a more powerful integrated circuit, a chip, okay, commonly known as CCMP. This new protocol was based upon AES, okay. You should be familiar with AES. AES is the generally accepted strongest encryption that you can get, okay. For authentication and encryption, CCMP was more processor intensive. That's why we needed a new hardware with more powerful chips. So most APs had to be replaced with more vigorous, okay, hardware. WPA2 supports both personal and enterprise modes. We'll be working on the personal side here today, not the enterprise. The enterprise side is a little more difficult to crack. Basically, it uses a back-end radius server. So everybody has, like your computer system, when you log into your network server, everybody has a different password to log into WPA Enterprise. You can see right away the strength of that. Okay, everybody has a different password rather than everybody have the same password. And if one person knows the password, everybody knows the passwords. You know everybody's passwords. So when using the personal mode, the PSK, the pre-shared key password is combined with the SSID to create a pairwise master key. All right. So essentially, let's talk about this a little bit. The pre-shared key, right, is then combined with the SSID. So if the name of your SSID is Netgear, okay, then those two are going to be combined, the password and the name of the SSID, to create a master key. The reason for doing this is to basically defeat rainbow table attacks. Rainbow table attacks are where, as you know, are those attacks where you basically can take a hash and go and compare it to the hash on a rainbow table, and you find the match, and then you know the password, right? With the SSID being essentially salted into the password, then you would have to create a rainbow table for every SSID out there to create rainbow tables, which becomes a huge task. Okay, this is why when you buy an AP today, it comes with a unique SSID. So initially, you could create a rainbow table. So when Netgear created their APs, then it was possible to create a rainbow table with all the possible passwords or common passwords, and then salted with the word Netgear and create a rainbow table. Now, because the APs are all unique, right, then that makes the hacker's job more difficult. Not impossible, but more difficult. Okay, Sej has arrived. Yay! Welcome, Sej. We're just kind of going through some of the basics here. All right. So this salting makes it more difficult to come up with to crack the passwords on these systems. This is why you should have a unique name to your AP. Otherwise, you're making it easier on attackers. All right. The client and the AP exchange messages using the PMK to create a pairwise transient key. This key is unique to each user and session and was designed to make sniffing of Wi-Fi traffic more difficult. And then in recent years, we have WPA3, which is still being implemented. Okay. Wi-Fi hacking tools. Well, Aircrack NG Suite is the key. It's built into many other tools. Nearly all the other tools are built around it. Okay. The first step, okay, to getting started in Wi-Fi hacking is to put your adapter into monitor mode. All right, so let's go ahead and do that. All right, let's go ahead and go back to our Kali. And let's go open up over here. You can see we have WLAN 0. All right. Also, I just want to show you a couple other commands that are useful working in Wi-Fi. So, for instance, of course, you can use the ifconfig, and you can see that lists all the interfaces. Specifically to Wi-Fi, we can use the iwconfig. And of course, it's going to come back and tell me, no, command not found because I didn't use sudo. All right, iwconfig, give it my password. And you see it shows me just the wireless. It shows me all of the adapters, but it says there's no wireless extensions here. Okay. And then I can also go iwlist, sudo, iwlist. And you can see here's the help screen here. And let's go sudo iwlist and WLAN 0. That'd be our interface. See, all of the commands requires the interface. All right. And then scanning. And then it'll go out and scan. You can see the data starting to come up. Okay. Actually went through and got them all already. And it pulled data, key data, on all of the Wi-Fi access points in range. Okay, let's take a look at it here. Here's one. Here's the address right here. Tells me the channel, the frequency it's operating on channel 1, the quality, the signal level, the encryption. Tells me the ESSID is Mandela. Okay. It tells me it's in master mode. Okay. And some additional information. Tells me how long ago the last beacon was. Tells me it's WPA version 1. So using WPA 2 version 1. Tells me all the specs on it. There's another one here that's called, it's on channel 6. All right. It's also using 2.437 on channel 6, signal level, quality, encryption, ESSID. It's important to point out here a couple things. Okay. One is that most Wi-Fi security managers are taught that they should turn off the SSID. Maybe even taught that. Okay. And that's a good practice to do that. Turn off the SSID. But for the hacker, that really doesn't make any difference because the hacker can still get your ESSID because it sends out a beacon every so often. All right. And that beacon is going to contain the ESSID. In addition, the hacker doesn't require the ESSID to hack it. All right. So what they need is this address right here. This is the MAC address, or what we talked about earlier as the BSSID. All right. So some basic commands to gather information about the Wi-Fi signals around you. All right. Then we can go sudo. Let's put our Wi-Fi adapter into monitor mode. Okay. Let's go sudo airmon ng. All right. And then go the name of the adapter. All right. WLAN 0 and start. My bad. The start should come first before the adapters. Okay. And now it'll go through and put the adapter into monitor mode. Now it changes the name of the adapter when it does that. Let's read what it has to say. It says found two processes that could cause trouble. Kill them using the airman check kill before putting the card in monitor mode. They will interfere by changing channels and sometimes putting the interface back into managed mode. Now, I've not had that problem, but let's do that anyways. All right. Sudo, okay, airman ng, and then it goes check kill. By the way, airman, like almost all the tools we're going to be using here initially, are part of the air crack suite. So people talk about air crack. So for instance, if you go up here and look at wireless attacks, you'll see a number of these tools here. All right, there's air crack. But air crack is a suite of tools. Okay, and these include air mon, air replay, air dump, air crack, air. Yeah, there's a number of them. Matter of fact, let's take a look and see if we can find them all. Go locate. Okay, air, and then let's put a wild card after it and see what we can find. Didn't find any. Uh, why didn't I find any? You should find everything that begins with air with a wild card after it. Let's try another command. Let's try. Oh yeah, thank you, David. that'll. Let's try. Yeah, so it's actually looking for air, and then. Yeah, thank you. Just use locate air. Yeah, that'll work without the wild card because it'll look for that fragment. All right, locate. My system seems to have locked up here. Come on. Something is lagging here. Come on. Sometimes there we go. Sometimes when I'm doing classes here, the GoToMeeting can use a lot of resources. Okay, locate air. Oh my goodness, we got so many options there. Okay, let's go up and look above here. Yeah, here we go. So air crack, air decap, air decloak, air lib. Okay. There's a bunch of other parts of the air crack suite there. Okay. So looks like somebody else has joined us here. Okay, we got James. Good. And Sej and David. Good. All right. So when we left off, we were looking at our putting our adapter into monitor mode. Let's go back now and go sudo ifconfig. You can see that our adapter has changed names. Okay. It's now WLAN 0 mod. So now, whenever we're working with that adapter, we have to use that name. So let's go ahead and let's try using sudo, another one of the aircrack tools. Okay, it's called aero dump, and then WLAN 0 mod. Yours may be different. Okay, the key is to find out what is changing your name. This is typically what it's going to be. All right, if you're using Kali, you're using any of the Debians, it's going to be WLAN and then some number and then Maal. If you're using, say, Ubuntu, it's going to be different. If you're using any of the other well, Ubuntu is Debian based too, but it has a different naming system. Let's go ahead and try air dump. Air dump, what it'll do is it'll go out and grab all the information of all the traffic that's going around us and put it up onto the screen. Remember we talked about putting your adapter into promiscuous mode. We've done that, and now we're going to go ahead and use that to see all the traffic around us. So let's go ahead and hit enter. And it'll start to collect. You can see it's scrolling through the channels, right? And up here, what we're seeing are all the APs. What we're seeing down below, okay, are the clients. All right, so if we wait a little bit, we'll see more information. All right, so you can see there's a number of APs nearby. Let's give it a little time as it collects all the information. So what I was saying earlier is that two of the most common practices that the people that security, hey, we got a new one coming in, a new client coming in here. That security manager taught is to turn off the SSID and possibly use MAC filtering. Okay, use MAC filtering, and MAC filtering can be used to limit who can use the Wi-Fi AP. Okay, by MAC, and remember that MAC is globally unique. So that sounds like a really good practice. I can say, okay, here's everybody in my office, and here's their MAC addresses. I will go ahead and put in a whitelist in my AP that says only these MAC addresses can connect to my AP. That's that's a good strategy, except that it's pretty easy for the hacker to be able to change the MAC address, okay, on their adapter to anyone that is already on the whitelist. And we can see the MAC addresses here of people who've connected, okay? So you can see, let's look at each of these, and I'll explain that further, all right? So here we have the BSSID, all right? That's the MAC address of every AP, all right? We got another one connected here, all right? So we got 4 clients, it looks like now. And you see that here we have 3C, right? This is the BSSID, 3C67. So we have these 2 clients, okay? This is the network adapters right here. That's the network adapters MAC address. So if somebody had put into place MAC address filtering, we can simply spoof this MAC address. We know that they are on the whitelist because they're connected. We can spoof that MAC address and connect to the AP. So yes, those 2 practices are good practices, but it's easy enough for somebody with some basic skills to be able to overcome them. All right, but it'll keep out the honest people. It won't keep out a good hacker. Let's go back through this information. MAC address of the AP. You can see all of them here. They're all globally unique. The power, the number of beacons. Now the beacons is a frame that is sent out as from the AP. And that beacon includes all the information you're seeing. Basically what we're doing is we're grabbing the beacon and getting information on the BSSID, the ESSID, and the security. So even if the SSID is turned off, the beacon still includes the SSID. Then we can see this one here, the number of data. This one looks like it's inactive, this one here. There's no data going across it. All right, and it's on channel 1, megabytes. The encryption is WPA, okay, CCMP, pre-shared key, and there's this ESSID named Mandela, okay. And then we see another one here. This one is more active, all right, and it looks like it's using WPA2, pre-shared key. And we can go through each of them here. You can see there is one here that's WEP, okay. Now, in reality, you may see something different, but you're not going to see many WEPs anymore. This is one that I actually just have built in my lab. I kept old Wi-Fi APs around. This is one that I've had around for a number of years, and it's still using WEP. And that's just for this course. If you were to go into like a big city and just do a scan like this, you would probably find a few WEPs for people who just haven't bought one in 15 years or so. But it's becoming rarer and rarer. It used to be that I would go downtown to a big city and might be able to see 25% of the APs having a WEP. Not the case anymore. They're getting rarer and rarer. So this gives us all of the information that we need to hack these systems. All right. Here down below, we can see all of the clients. All right. These are the MAC addresses of the clients. And for instance, this one here, these two here, we're picking these up, but they're not associated with any, they haven't connected to any of the APs. This one here, for instance, has connected to right here, the Verizon. All right. This one here, okay, has connected to Magic Cabin, and the other one, that one just went away, and the other one had also, there we go. And we've got a couple other, these are associated with the LTE CPE. So once we put it into monitor mode, all of a sudden we've got a whole lot of information and everything really that we need to start hacking these APs. All right. Let's just sit and watch this for a little bit and you can see. Now I mentioned you can see more of them coming on, more clients coming on. If I go ahead and take my my alpha Wi-Fi adapter and lift it up over my head, you will see, watch. Okay, it'll start picking up more and more. Yeah, so far it's picked up more clients, not more APs. I live in a pretty remote area, not many neighbors. When you're in a big city, you'll pick up maybe hundreds of these. I'd mentioned the possibility of how you could change your MAC address, all right? So if somebody has, for instance, um, MAC filtering in place, we could go ahead and change our MAC address to one of those MAC addresses that have already connected, all right, like the ones we see here. We know that these guys were on the whitelist, right, because they've already connected. So how can we go ahead and do that? How can we go ahead and change our MAC address? Well, first thing we got to do is to take down I'm gonna run the commands. And first what we got to do is go sudo, all right, and then we got to go if config, and then WLAN 0 mod. Oh, gotta make that a 0 mod. And then down. All right. Now, if I do this, we're going to lose this connection. All right. And I'll show you. Let's go. It's okay. Go down, go Cali. As long as I don't lose my connection to you guys. And as it should slowly see the screen begin to, all of the connections fade away. It should. Let's go and do a sudo ifconfig and see if it's down. Ifconfig. Looks like it didn't take it down. All right, let's try that again. IF is not going to work. Let's try IF down. Comes back and says unknown interface. Okay. Let's go sudo ifconfig. There's the interface right there. Doesn't want to take it down. Sudo ifconfig. We'll try different commands and see if we can get it to come down. Looks like things are frozen over here. It's frozen over here as well. Can you guys still hear me? We're not frozen? Yeah, okay, good. So we're not frozen. Just my virtual machine seems to be frozen right now. And it appears that my virtual machine has frozen. I'm gonna go ahead and reboot it. Let's take a 10-minute break. I'll reboot it and we'll start. See if we can get this started over again. All right. So you're off for like 10 minutes. Okay, we're back, and my virtual machine crashed. Now we're going to go ahead and see if we can get it back to the same place it was. Okay, you can see that it's reverted to WLAN 0. All right, so we got to go ahead and go sudo sudo air mon ng and then start WLAN 0, whatever the name of your adapter is. Okay, it's changed it to WLAN 0. So now we can just go sudo air mon ng to get the, I'm sorry, not the mon, we want the air dump. Air o dump ng and WLAN 0 mod. And let's see if what we can get here. I'm not getting anything now. Let's close that down. Let's try again. All right, let's go sudo, see if we can figure out what's going on. First of all, let's make sure that the device is connected. I'm pretty sure it was. We saw it right there. Okay, it's connected. Go sudo ifconfig. There's our WLAN mon. Let's go sudo air mon ng check kill. That's the thing we didn't do. It's trying to kill. We're trying to kill the processes that were potentially causing us problems. All right, and then go sudo arrow dump. This is O and not a 0. Air dump ng, then WLAN 0 mon. And now we're not getting any. Let's wait a second, see if it picks up anything. Right now we're not getting anything. Now, one of the things that I have found in using VirtualBox, and by the way, I find that VMware's workstation is more reliable. I use the Oracle VM VirtualBox just for classes. In my own work, I use VMware. I use it for classes because it's what most students are using. It's about $250 to get the VMware workstation. Obviously, Oracle VirtualBox is free. Now, one of the things that I've found, I'm going to go ahead and shut this down. The problems that I can get with in VirtualBox is in the settings and the USB. All right. So I'm going to go ahead and shut this down. And we had it working, right? It was working great. And all of a sudden now it's not. Let's go to settings and let's go to USB. And this is where I've run into problems, okay? Is notice I've enabled the USB controller, okay? And I've got two adapters, okay, that are in my device filters. And I've enabled USB 3. All right, so if it's not working for you, try this, okay? I'm going to go ahead and switch over to USB 2, okay, and see if that'll make any difference. And then we'll go ahead and try again. Now, this is basically a virtual machine issue. It's not something you'll see in a physical machine. All right, let's go try again. And let's try make sure under devices, USB, you can see it's connected. All right, let's go here and let's go sudo ifconfig. Okay, there's our WLAN 0. Okay, good so far. Go sudo air mon ng start and then WLAN 0, putting it into monitor mode. All right. There's our command. They're asking us to use the airmon check kill. We'll do that once it's done. Putting it into monitor mode is change its name to WLAN 0 mon. And now we're going to go sudo airmon ng And then the name of the adapter. No, we're gonna use the Earmon ng check kill before we go any further. Check kill. Okay, good. Let's go sudo ifconfig. Make sure everything's correct. Looks like the air WLAN mon right there is set properly. And then we're going to go sudo aero dump ng. All right, and then the name of the adapter. Okay, WLAN should be 0, not O. That's a number. Okay, and we're still having problems with. Let's see what I can do here. Are you guys still there? Lots of unusual noises. Okay, so let's go back here. Go devices, USB. Looks like I'm gonna disconnect it and reconnect it. Okay, so make sure that my device is connected. It is not. Okay. Okay, it says fail to attach USB to virtual machine. All right, that's by disconnecting it and connecting it again. All right, let's try. Okay, tells me that. All right, let's go here. Go to USB. There it is connected. Looks like it is. Let's go and test. Let's go sudo ifconfig. And it's not attached. Disconnect it again and connect it. Once again, this is a virtual machine issue. Looks like it's connected. Let's go ifconfig. Still no connection. All right, one more possible solution here. Let's go back and change our USB settings again. Boy, paying a heavy price for trying to take that adapter down and and change the MAC address. I won't try doing that again. All right, let's go ahead and go change it to USB 3 again. Let's start it. Yeah, exactly. That's life. That's life in general, and it's particularly true in IT, and particularly true in virtual machines. Virtual machines are wonderful, but they do have their anomalies. And the reason, those of you who are watching the video, the reason I'm including this in the video is that you might have similar problems. All right. I mean, I get all the time. I get emails from students who have similar problems. So I thought we just put these into the video so you can kind of see how we can potentially work out these kinds of problems. And if you watch a video and everything works perfectly and flawlessly, that's not really how it works. Okay, there are always problems. All right, and you have to figure out how to get around them. That's part of doing IT. That's part of life. All right, I'm getting good signals here. Let's go and try USB. It looks like it's connected. Okay, let's go back to sudo ifconfig. Yes. Okay. So at least for now we've got WLAN 0. That's a good sign. All right. It looks like we're going to have to keep it on USB 3 and not USB 2. It's not going to work under USB 2. Then let's go to sudo airmon ng. Let's go back and put it into monitor mode. I'm getting a nice flash out of my adapter. That's a good thing. If you're using the alphas, generally if they're connecting and communicating, you'll see a flashing light on it. And if you see that flashing light, you're probably in good shape. All right. Start WLAN 0. All right. And then let's go and do our check kill sudo airmon ng check kill any of the processes that might be interfering. Good. And then let's keep our fingers crossed and pray to the hacker gods that arrow dump WLAN 0 mon will give us a nice dump. So it's arrow dump ng. And it's not appearing to cooperate. Yeah, you just start. David says he's got to restart his machine as well. This happens. So that's why I'm leaving this into the video so you can see that the problems that you experience are not unusual. All right. I am not getting anything from my adapter. Let's go ahead and do a disconnect and connect. And let's make sure it's connected again. There we go. Let's do a sudo ifconfig. No adapter. Let's try connecting it again. Still no WLAN 0. So I'm going to physically disconnect it and try again. Can you hear me now, David? David, can you hear me? Okay, good. As I think I was saying when you couldn't hear me, is that last time I taught this class a little over a year ago, I had similar problems with Oracle's VirtualBox. Um, I thought I had them all worked out before we started class, and we did. When we started class, it looked good. Um, and now, so one of the options we have is to go to VMware. All right, let's go sudo. I just hate to do that because I know a lot of people don't want to purchase VMware. All right, if we can, okay, we've got it. All right. All right, so now let's go and do sudo. I think we've got it going now. Air mon ng start WLAN 0. Okay, so far so good. Let's do our airmon check kill. You having similar issues, yeah? Okay. I don't have these problems with VMware. VMware works pretty flawlessly, but it's about $250, $300. And I said, I know a lot of people can't afford that, so that's why I'm trying to do it on the free virtualization system. All right, so airmon check kill. Let's get those. All right. And now let's try, keep our fingers crossed. We're going to do arrow dump. And then WLAN 0 mon 0, not O. Darn. Let's shut this down. Let's go. Remember we did the IW list. Okay, so sudo IW list. Remember that shows us all the APs in the area. Okay, IW list, and then our adapter. And scanning. Let's see if we can get a good scan from IW lists and see if it's issue that doesn't support. Okay, so I got to go ahead and let's go PSAUX. Let's go ahead and go sudo ifconfig, okay, and then WLAN 0. Oh, let's just do this. I got a better idea. Sudo airmon ng, okay, stop WLAN 0 mod. Okay, then go sudo ifconfig. All right, so now what it's done is it's disconnected the adapter entirely. Shows that it's adapted here physically. Okay. Let's go sudo ifconfig WLAN 0 up. Now let's do our sudo if. That did it. Okay. Now let's try sudo airman ng start on WLAN 0. David says, is there a quick way to rename the interface? Why would you want to rename the interface? I'm not sure what your issue you're trying to resolve here. Yeah, you're just going to have to use that, David. Okay. It is easier. Yes. That's what I was pointing out is that yours may be different. David's got a very long and complex wireless adapter name. I'm trying to think, David, if there's a way to rename it, and I don't know of any right off the top of my head, but I have had similar adapter names come up, and I've just used them, just copy and paste it. When you go to put it in monitor mode, it'll truncate that name, if that's any help to you. So when you go to the Airman, Airman will come back and tell you, that name is too long. Okay. It doesn't do that? Hmm. And my Airman is hanging here. When I've used those long names and I go to Airman, it'll come back and say, hey, that name is way too long, so they'll truncate it to like WLX0 Mon. David's got one that's WLX00C0 CAA CF167. So if you get something like that, you know that that's not unusual. And mine is still trying to put my adapter into monitor mode. I think I'm going to kill this. Control C. Try again. And my virtual machine might have frozen up again. Let's give it a minute to see if it'll unfreeze. While we're waiting for it, I'm gonna show you some additional information that might be useful to you. All right, it probably, hopefully, will be useful to you in terms of Wi-Fi. Wi-Fi cracking, and that's basically the anatomy of these Wi-Fi frames. So give me a sec to pull that up, and we'll wait for my virtual machine to get out of its funk. All right, let's go over here and go back to my presentation. We'll just wait for that system to kind of recover. All right. So if you're using the tools that are available to us. Okay, this is more information than you actually need. But if you're going to build your own tools, all right, then you need to understand the basics of the Wi-Fi frames, and that's what we're doing here. All right. And one of the things that we're adding to this class that we didn't do in previous class is go ahead and build ourselves our own Wi-Fi scanner. All right, so we're going to use some basic Scapy and Python to build our own Wi-Fi scanner. And you can see here, these are the Wi-Fi frames, right? And some of these frames are particularly useful to us, all right? So for instance, you can see here, there's a beacon frame right here, okay? And we can go ahead and use a Wireshark filter, WLAN, FC, type, subtype, and then the hexadecimal value 0x08. There's a probe response here. You see this one right here. You see it's a management frame. It's a subtype 101. There's a disassociation frame, right? So disassociation. Now we haven't talked about it yet, but it's possible to DOS a AP by simply using disassociation frames. And Aircrack has that capability, so does BetterCap. Okay, so what they do is that they send out frames that say disassociate. This is a normal frame that says I want to disconnect from you. Okay, or de-authenticate. Okay, these are both used, disassociation or de-authentication. De-authentication is more effective, and we can send these frames to an AP to knock everybody off it, and essentially DOS it. The authentication frame is here. All right. We can see some additional frames. All right. Some of the control frames. And if you want to know more about each one of these frames, you can see my article on Hackers Arise called The Anatomy of Wi-Fi Frames. This actually comes from that. All right, and I've gone ahead and listed all of the frame types. The ones that we're most interested in, though, are going to be these up here. Okay, so here we have the probe request, okay, the probe response, the beacon, the authentication, and de-authentication. And we can use those in our attacks against a Wi-Fi access point. In particular, ones we're going to be using are the de-authentication to be able to DOS it. And the beacon, of course, we know, I was mentioning earlier that even if the Wi-Fi administrator has turned off the SSID, the SSID is still included in the beacon frame. So, and that's not something, I mean, they can't turn that off and still have a functioning Wi-Fi AP. All right? So that's great to stop most people, but for the hacker with basic skills, they can still pick up that information. In addition, the beacon frame also includes the BSSID, and that's really what we need to attack the AP. All right, let's go back then to our virtual machine, see if we have any resolution here. Looks like we don't. Looks like my system is frozen. I'm just going to have to try one more time. Shut it down. Start it again. All right, let's go back. I'm not sure why it's freezing, other than GoToMeeting using too many resources here. That's a possibility, because it usually works pretty well in the lab environment. Occasionally I'll have problems, but not like this. Okay, let's go open up a terminal again. Let's go and check our devices, USB. Looks like it's connected. Okay, then go sudo ifconfig. Good. All right, good so far. Then go sudo airmon ng start wlan 0. Okay. You can see it's changed its name. I'm going to try to not use the check kill and see if that'll make any difference here. Sudo aero dump ng wlan 0 mod. And unfortunately, we're still not getting much of anything. Even though it says it's connected. Let's stop this. Let's go sudo airmon ng stop wlan mon. Okay. And now it should be back to its old name. Go sudo ifconfig. There, it's back to its old name. Now let's go sudo iwlist wlan 0 scanning. No scan results. Sudo ifconfig. Looks like it's everything. Looks like it's connected. Still no scan results. So even though it's connected, it apparently is not sending out any probes. Let's take it up and down. Okay. WLAN 0 down. And then do the same thing and bring it up again. Up. Then do our sudo. It's there. Let's try scanning. No scan results. One other thing I'm going to try, and that is using a different adapter. All right, let's try Be right back. I'm going to grab another adapter and plug it into my machine. Okay, this is once again, another alpha. Slightly different model of the alpha. And they never show this stuff in the Hollywood movies. No, and partly you wouldn't expect them because they're really using a virtual machine. This is really a virtual machine issue, right? This is not a physical machine issue. All right, so here's the new one. It's a real tech right here. All right, and then let's see if can you hear me? I think I did kick myself out temporarily. Okay. All right. Let's try this new adapter. Let's see if first of all, see if we can get it to connect. It looks like it's not connected. All right, you can see it's right here. It looks like it's physically connected, but not showing up in my IF config. Let's try rebooting this system with this new adapter. See if we can get it to connect. And if it doesn't, we'll just go on and do some of our build our Python scanner, and I'll work out the issues overnight. So when you're having similar problems at home, you know you're not alone, right? And these are Oracle VirtualBox issues. All right, these are not issues with your adapter. They're not issues with your operating system. They're issues with VirtualBox, unfortunately. And it's one of the drawbacks of using a free VM. All right, we're back up. Let's see if I can get this other adapter to connect. And USB. See, I've got two of them the same, which is confusing. All right. One of them I'm using to connect to you, okay, on my physical machine, and then one I'm connecting. So I gotta take a guess and see which one is the right one. I think it's this one. If I drop you, all right. Looks like I haven't dropped you, so got the right one. Let's go and look at USB. Looks like I've got it. You can still hear me? Haven't disconnected? All right, now let's go ahead and see if we can't get this one to work. Go sudo if config, and it doesn't want to. It doesn't want to connect. Okay, I'm sufficiently frustrated at this point. So what we're going to do instead is I'm going to show you the Python Wi-Fi scanner, and then what we'll do is we'll go ahead and I will either for tomorrow's class I will either get it working or I will use VMware's workstation. I prefer not to use VMware workstation because I know that everybody else is using VM Oracle Box or Oracle Box, and but on the other hand, I've got to get this to work. So I'm just going to give it one more shot and see. Okay, looks like it's there. It still didn't connect. It says failed to attach the virtual machine. Okay. Let's try again. It shows it's attached. There's one more of those anomalies of working with Oracle's VirtualBox. It shows me it's attached, but it's not. Nope, not attached. Okay. Can you hear me now? All right, good. All right. So what I was saying when you couldn't hear me, what happened is that I was changing the Wi-Fi adapters. I apparently just nudged the headset connection, USB connection, enough that it wasn't connecting. You weren't hearing me. So what we're going to do now, since we can't get the Wi-Fi adapters to connect like they should, we're going to leave the hacking part till tomorrow. Okay. And either we'll use VMware, okay, or I'll work out the issues with Oracle VirtualBox, one or the other. Either way, we'll do the hacking tomorrow. But obviously, we're out of luck this morning, and so or afternoon for you guys, okay. And so what we're doing is we're building a Wi-Fi scanner that essentially is going to do almost the same thing as what the air dump command will do in the aircrack suite. All right. And to do this, we need to use a tool called Scapy. And what Scapy does is it takes the traffic and puts it into a PCAP format. Right? PCAP is that same format that say Wireshark and Snort and other tools use. So by using Scapy, we can go ahead and grab every packet, put it into a into a PCAP format, and then we can work with it. And so that's what we're going to do. So it's not that complex of a scanner, all right? And it's not that complex of Python. But I think it's a good exercise to learn a little bit more about Wi-Fi and learn a little bit of Python while we're doing it, okay? So after we've imported our modules, all right, we're going to go ahead and create a function, okay, to handle when the user enters the control C. That's the first thing we're going to do. So function to handle, and we're just going to create some functions. Then the main body of the Python is going to use, okay? When the user enters C plus C, okay? Control C. Basically, it's a function that's going to say stop things, okay? So it's going to be signal handler, signal frame. Now, in Python, the code blocks are basically indentation. So standard is to use like four, either tab key or four spaces. So go ahead and then go print. So we're creating a code block here. This is just a print statement. We make several print statements. Execution aborted by user. And so these are just what the system's going to say when somebody uses a Control C. Okay, and then we're gonna print. I'm sorry, we got all the prints. I'm gonna do a OS, the OS module, OS system, and then it's gonna go ahead and do a kill -9, okay, which is the kill everything, and plus the string, okay, of the OS get PID, get the process ID, so it can kill it. All right, let's see if we got all our paren set up. One here. Looks good. All right. And then sys exit. Okay. That's our first function. Then we're going to create a function to exit. And this is going to be basically define. That's what the def is. Defining a function. Signal exit. And it's going to be signal frame. And then we're just going to go print. Signal exit. And this is just leaving the scanner, and then we're going to do a sys exit. Okay, so we got two functions. Then we're going to create another function to remind the user of the basic syntax. Okay, so we're going to tell them, okay, this is the syntax that you need to use to be able to use this tool. Create a function to remind the user of the basic syntax if they do enter it incorrectly. If incorrect. So they shouldn't get this message if they've entered it correctly, only if they entered it incorrectly. So it's going to be def. We call this one usage. Okay, if the length of system argument is less than 3, okay, print usage. Basically, it's going to print a new line and say usage, okay? Then print Wi-Fi scanner PY. This is the syntax they need to use, and then the interface. So it's just kind of a usage statement saying this is the proper usage if you've entered it incorrectly. All right, and then we'll do a sys exit. It's again relatively simple. I missed the opening bracket. Okay, yeah, and the print statement I did. Thank you. keep me honest here. All right, we'll keep on going here, building our Wi-Fi scanner. So this is the key. This is the key element here. This is sniffing the packets. Okay, so we're going to go ahead. Go create a function. It's going to go ahead and create the packet sniffer. All right, we create a function to sniff packets, and of course, this is going to be using Scapy. It's going to define. We're going to call this one sniff packets. So we're going to use a try block. Okay, a try and accept block. Okay, so try. We're going to go ahead and go source. We're going to get the source MAC. All right, is equal to packet, very first packet. And then we're going to get the destination MAC. And that's going to be packet, it's also from packet 0. ADDR1. And then we're going to get the B SSID. All right. Remember, that's the MAC address of the AP. That's going to be from packet 0. And ADD. So this is that third field in that packet. All right. Then we're going to, that's a try, then the accept. We're going to do some print statements, okay, if there's an error, okay. And we're going to say print, okay, cannot read MAC address. And then we'll create print, and then the string of the packet, and encode in hex. And then we'll exit. Sys clear. And then we're going to create another try statement. 1, 2, 3, 4. Try. This is going to be SSID size is going to be equal to packet and then we use the dot 11 ELT. This is from the Scapy. Okay, so we're going ahead and getting the packet, the SSID from the packet capture from Scapy. And length, we're capturing the length of the SSID first, and then the SSID going to be equal to packet 0 dot 11 ELT dot info, and then we'll do our accept. Yeah, David. Yeah, these are all Scapy features. Okay, Scapy is a really powerful module that you can use in Python that basically takes packets and puts them in PCAP format, and then once they're in PCAP format, you can do all of these operations on them to pull the information out of the packet. That's what we're doing here. We're going ahead and we're capturing the packets, and then we're going ahead and doing these operations to capture the source MAC, the destination MAC, the BSSID, the SSID. So we're getting all that information that we can use in our scanner. So good question. But yeah, Scapy is really powerful in creating these features. Primarily what it does is it allows us to manipulate packets, okay? And it's a module in Python. SSID then is going to be equal to, and so building a scanner, we need the Scapy. We could build it without Scapy, but it'd be a lot more difficult. All right, so that's one of the key elements right here is this sniff packets function, okay? Now, as we saw earlier, okay, we're looking for, we talked about the anatomy of these frames. We talked about the beacon frame, okay? So one of the things that we need is that beacon frame. The beacon frame is going to have the key information that we want. So let's go back, and I'm going to put that back up on the screen for you and show you what we're talking about here. Let's see if I can find that slide for you. Here it is. Okay, so here's the beacon frame. I don't know if I'm going to expand this on the current slide. All right, you see the beacon right here? It's type 0, okay? And then it has a subtype 08. So to be able to get our scanner to work, we need to first be able to identify, okay? Can you guys see what, are you guys seeing okay? There we go. Okay, it looks like things are slowing down. There's a little bit of lag between what I'm putting on the screen and what you're seeing. But here's what I wanted to show you is the beacon frame. All right, this is what we're looking for because this has the key information. So our scanner has to identify the beacon frame and then pull the information out of the beacon frame. So here it's type 0, subtype 8. So that's what we're looking for. All right. That's what our next function is going to do. Is go ahead and look for that beacon frame. All right, so in our comments, I'm going to slow down here a bit, let our screen catch up. Okay, the screen is caught up now. You can check to see whether the packet is type 0 and subtype 8. All right, that's what we're looking for. That's the beacon frame. So to do that, we're going to go if packet if packet is 0 type, okay, then we create a variable. We're looking for the subtype now. That's what the ST stands for. If the packet zero dot 11 subtype whoops, and then if the string of the subtype is equal to 8, that's what we want, right? And the SSID is not equal. I'm trying to remember on my keyboard how I can make that not equal sign. It's not equal to blank is what we're looking for. Hang on one sec. All right, I guess it's the Alt key. Okay, so Alt equal. This keyboard's not working. Let's try it again. Alt equal. My keyboard is a little bit strange. This one here is sometimes has different keyboard combinations, but let me see if I can get it. Yeah, that should work. David says just use the, there's actually another, there's a way to go ahead and put the slash, there we go. Thank you. Does not equal. And does not equal a blank, all right? And the destination MAC is lower than FF, FF, FF. In other words, less than the broadcast MAC address. And then we're going to go create a variable called P. We're going to put the packet into it. The dot 11. And then create another variable called cap. This is going to be packet sprint. And here we're going to print the .11 beacon. This is basically taking the keycap of the frames, okay, and printing them out for us. In this case, yeah. And then I'm going to continue on to the next line. And then we're going to print out the probe as well, the .11 probe. All right, make sure I have that all. Missed that quotation mark there. And then channel is equal to none. And crypto, the type of cryptography that's using is set. Okay. Now we're going to evaluate the cryptography type next. All right. So this one here is making sure that it's the beacon frame. Okay, that's what we're doing here. So all that's doing is checking to see if it's a beacon frame. Then next we're going to go ahead and check what type of cryptography it's using. Okay, so while, we create a while is instance p dot 11 ELT should be a space there in that while statement. Yeah, thank you, David. You're right, I did. Thanks for catching that. Then we're going to do a try. As you know, try allows us to keep on doing something until we hit an exception. Okay? So we can try if the P ID is equal to 3. Let me fix that. Then the channel is equal to the ordinal number of P info if, this is else if, right? Else if the PID is equal to 48, that's the identifier for WPA2, okay? Then the crypto add, we'll put in WPA2, WPA2. elif, it's not that either, PID is equal to 221 and P info starts with, we got my S in there, starts with, and then what we're looking for here is some hex, okay, that we will indicate that it's WPA. So these hex figures will indicate WPA and not WPA2. So what this is saying here is if the PID, okay, this would be the crypto ID, all right. This should be, fix that channel right there, channel, okay. And then if the PID is equal to 221 and it has this crypto, right, then it's going to be WPA. See how we're identifying the cryptography here that's being used. And then the accept, and P is equal to the P payload. And basically what we're going to do next is we're going to check to see whether or not the way that the packet indicates WEP is different than the way it indicates the WPA and WPA2. Okay, so we got to do a little slightly different algorithm to check to see if it's WEP. All right, so that's what we're going to do next. I'm going to put a little note in here. Check whether privacy is in the packet. That's an indication that it's using WEP. All right, and then if not, then we're going to consider it open. Okay. So if not crypto, in other words, it hasn't captured anything into the crypto, so it didn't find a 3, a 48, or a 221 in the crypto field. It didn't capture anything there, right? Then if privacy in cap. Crypto add, we're going to call it web. Okay. Else, so if it doesn't find privacy in there, crypto add, we're going to call it, let's call it open or OPN, either way. Okay. So if it doesn't find the privacy, then we're going to, David says, mess up the double quotes in the starts with brackets. Did I? Okay, yeah, I did. Thank you. Yeah, there we go. Got it fixed now. Thank you. If you see any others, let me know. You can tell I don't type very well. And so I'm going to make a fair number of mistakes. So what we've done here is that we've gone ahead and checking to see what type of crypto it's using. Remember that we did the arrow dump. It identified the BSSID, the SSID, the type of cryptography. So that's what we're doing here is we're trying to capture this information from the frames that we can then display, okay, on the screen, very similar to the air dump tool. All right, so we've gone ahead and we've identified wet. All right, good. Then let's go ahead and what we're going to do now is we're going to go ahead and look. What this next section does is it checks to see whether or not the SSID is already in our list. In other words, the beacons are coming out constantly, right? And so in our scanner, we don't want to keep on relisting the same AP. If it's already been captured and already been listed, then we don't want to continue. So that's what this next section does. It goes ahead and checks to see whether or not the source MAC address is already in our list. If so, it doesn't display it again. Okay, so let's go if the source MAC, okay, that would be the MAC address of the AP, is not in the SSID list keys. If it's not there, then go ahead and list it. If it is there, then don't list it. If zero zero 50 F204 104 A 0001104 is in, I'm taking a string of the packet, encode and hex, okay. Now this is actually, I stand corrected. This is a section where we check to see if it's WPS, okay. WPS being the simplified method of connecting to Wi-Fi APs. Okay, so we're looking for this in the packet in hexadecimal. If it is, then it's using WPS. We haven't addressed WPS yet. So here we go here. WPS, and then we're going to get a print statement that's going to show us okay. David's pointing out that I've missed a few other yeah, thank you. The dot between the string and the encode. Thanks. And points out I missed some. Yeah, thank you. There we go. And I missed this one over here too. I missed quite a few. All right, good. Moving on. This mouse pad is not the best tool for being able to write Python. Um, something like PyCharm will catch these kinds of errors automatically. In this case, we got the WPS up, and then we're going to go ahead and do some print statements. These are print statements. These are primary print statements that our scanner is going to print. Okay, it's going to use the information, okay, that we've captured, and it's going to include the channel, the B SSID, the encryption, and the SSID. So this is all the information we've captured from the packet. We could capture more information, but this is certainly adequate for our purposes. All right. And then we're going to go ahead and print the new APs. We're going to put in a little plus showing that it's a new AP plus. New AP. And the channel these are just showing us the fields to print the information. Okay, so we're going to go T, and that's going to be the second field. And then the third field, up to 5 characters. This would be the SSID. Get that into curly braces. And then format, channel, G, SSID. We have to put in an escape character. and then join crypto, and finally the SSID. Let me make sure I've got all of that correct. All right, let's see, new AP. Okay. Looks good. Format, channel, BSSID, crypto, and SSID, double quotations. All right, good. Okay, open double quotes. Yeah, that print statement needs a double quotes, right? Thank you, and it closes. Double quotes are closed right there. Okay, good. And then we need the SSID list. I'm creating an SSID list that we used earlier. SSID list. Make sure I got that spelled right. This is going to include, of course, the source MAC. So this is where we're checking to see whether or not the source MAC address is in this list. Okay. Actually, we're creating a list right now. Okay. So when it gets a new source MAC, it puts it into this list. All right. And then we can check the list to see whether or not it's already been listed. So it doesn't keep on listing the same AP over and over again. Then we're going to go ahead and create a function to automatically put the interface into monitor mode. All right, so we know that we need to go ahead and put, whenever we're doing any work on these wireless, we need to put the adapter into wireless mode. So our script's going to do that automatically. All right, so we're going to, let's go ahead and put a comment in there and say define function to automatically place interface into monitor mode. So if it's not in monitor mode, we'll put it there. We're going to create a function. Okay, go setup underscore monitor. And with the interface. Okay. And then we're going to make a print statement. Print. Setting up. Sniffing options. Need to close this quotation mark right here, parentheses. And then we're going to use our operating system module for operating OS system. And we're going to use the system commands ifconfig. Plus the iFace. So we're putting the interface down first using the operating system module. So we can use operating system commands. And then we're going to try OS system. We're going to use the iwconfig command. plus the interface. Mode monitor. We're checking to see if it's in monitor mode. If it's not, accept. Print. Failed to set up your interface in monitor mode. Sys exit. And then we'll go to using operating system again. We'll go ahead and put the interface back up. And then we'll return the iFace. Okay, almost done here. Okay, David says needs a blank before the down. Yeah, you're right. Thank you. Good. There's a blank there before the up. Okay, good. Catch anything else, let me know. Okay, now here's where we're going to go ahead and we're going to check to see whether or not the AP is in our list. Okay, we talked about doing that. We created a list up here, right? So it's capturing the SSIDs, and we're going to check to see whether or not it's already in the list so we don't keep on printing out the same AP's key features, right? So these beacons are coming out constantly. Our scanner is going to capture those beacons, grab the information out of them, and if we don't tell it to not keep on repeating for the same AP, it will. So here's where this is the function that's going to check to see whether it's in our list. All right. So here's going to, we'll put in a little comment here. We're going to create a function to track already discovered AP SSIDs. Okay. So as to not list the same ones. Since the beacons are coming out continuously, we have to make sure that we're not just keep on printing out the same AP over and over again. Init process. Make a global SSID list. Make that global. And then SSID Okay, I'll get to that, Dave, in just a minute. Let me finish up this last function. And I'll take a look at what you're asking me. Just making this last global S, and then S is equal to configure L2 socket iFace is equal to new iFace. Okay. Now, see, David says, not sure if it works as a blank between the command and the opening bracket, like the last OS system statement. Okay, let's see. Right here? Yeah. Thank you. Yeah. This one here as well. Okay, got a couple of those. So thank you. Once again, this is why you want to use something like PyCharm or another IDE that's specific to Python. It can pick up these kinds of errors as you're typing them. Okay. And let's see, we got the SSID list. What else do we have? Oh, we also got to check to see whether or not there's root privileges, right? Notice we always use sudo in class, right? So now what we have to do, we're using the scanner. We got to make sure that the user has root privileges. So that's what we're going to do next. This is a function that's going to check to see whether or not they have root privileges. Sudo, I'm sorry, define a function to check whether root privileges. Yeah, David says he's the pie charm today. He is. He's my pie charm, checking for my errors. All right, so we're going to call this function check. Check for root, and it's our new function, or maybe just my IDE today. Okay, um, let's go if not. Okay, spell not right. If not, OS get UID. All right, so get the user ID. If when it gets the user ID, all right, and it's not 0, which is root, okay, then we're going to print you must you must run this script with root privileges and then exit. Let's see. Yeah, that one looks good. Almost done here. And then we're going to just put together the main body. So we've got all these functions. We've been able to, one, identify whether or not the beacon frame, extract the key information from the beacon frame. We have created functions to determine what type of encryption is being used. We've created an SSID list so we don't keep on repeating the same SSID. And now we're going to use all of those functions to print out this information on all of the APs around us. All right, so this is going to be the main body. So then we'll be all done. Main code body. This is a lesson in Python, Scapy, and Wi-Fi anatomy. All right, so hopefully you get some idea of what it takes to be able to create a tool. This is a relatively simple tool in Python with Scapy. And all we're going to be doing is then printing out the key information similar to the air dump command in aircrack. All right. So if name is equal to main, all right, let's see, got that right. If name should be equal, sorry, let's get that. There we go. Okay, signal, 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 sigint, signal handler. You check that statement. Some typos here. Signal, signal, sigint, signal handler. And then remember our usage, okay, function. We're using it here. We're going to use our other function of check root. And then our parameters. Parameters. And then parameters. I'm sorry, I'm just repeating that line. All right, then if mon, okay, not in the string parameters, and let's see, we're checking for the dash I, right? Let's make sure we have that double quotes in there. Okay, like that. If the dash I is not in there, in the parameters, we're checking here now that, okay, so sorry, we'll resume tomorrow. Sage has to go. We'll finish up what we're doing here. Got a couple more lines to enter into our Python script here. We'll test it tomorrow, and tomorrow we'll get our Wi-Fi adapter working, either in VMware Workstation or in Oracle's VirtualBox. So we'll see you then. We're almost done here. All right, let's go. David says check root. Okay. Thank you. Underscore, not a dash, but an underscore. My PyCharm is working. Checking all my errors. So if mon not in the, if we don't have the parameter dash I, all right, in there, then new iFace setup monitor with the parameters dash I. Just a few more lines to go here. Okay. Oh, come on. I'm hoping it didn't crash. Okay, good. All right. Else. New iFace is equal to string parameters with the dash I in it. Just basically making sure there's a dash I in the parameters. That's all it's doing. And then we're going to go and initialize the process. And then we're going to do our print statements with all the information that we have. Okay? So print starting hackers arise Wi-Fi sniffer. Now, this is not a Wi-Fi cracker. All it is a sniffer, very similar to the AirMon that we used earlier as part of the Air Crack suite. All right, let's put in our double quotation marks around our print statements. Okay, and then we're going to go ahead and print sniffing on interface, and then we're going to concatenate that to the string of the new iFace, and then concatenate that with some dot, 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 dot. And then we'll start the sniffing. Sniff, double F, and we're going to sniff on iFace, okay, which is equal to new iFace, all right? And we're going to be using the sniff packets from above. And we're going to store equal to 0. Okay, I think we're done. Let me just do a quick scan of it, make sure. Signal, signal in, signal handler, usage, check root, parameters. If mon not in string, parameters not in the, doesn't have the I in there, the new interface setup monitor. Okay, let's get rid of that space right there. Else new interface, string parameters I, initialize process, and then start hackers arise Wi-Fi sniffer, printing on the interface, and then the name of the interface, dot, 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 new line, and then sniff iFace on the new interface using the sniff packets and store 0. Yeah, do you have more PyCharm for me? If you see errors, let me know. Just want to go through it and see if I see anything that's obviously wrong. I see this right here is missing a single photo code. Inline new interface. Okay, thank you. I'm not sure what we're talking about, David, but I appreciate your help. Where are you seeing that?
Can I say something?
What's that?
Because you have no line numbers. You have no line numbers. It's
Yeah,
very difficult.
right, exactly.
You have the statement new iFace equals set of monitor parameters. You have a double quote in the beginning of the
There you go.
-I and a single quote at the end. I
Now
think
you have line numbers. Hang on a second. I just put in line numbers for you. Now, what line? You see the line numbers yet? You can't see. Okay, hang on a second. There, it should popped up just now. We're getting a little bit of lag between what's appearing on the screen and what I'm doing. Okay, what line number? 137? Okay. New iFace. Okay, thank you. I see it now. All right. Is there any more of those? Scroll up. If you see anything, let me know. Okay, well, let's go ahead and we'll save for the testing of this for tomorrow. All right, we'll start the same time tomorrow. I may be using VMware. I'll work overnight to get this thing up and running on Oracle VirtualBox. If not, I'll switch over to VMware, in which case David is asking me to scroll up a little bit more so he can check my code. But we'll check it tomorrow, David, around line 90. Okay. I can see there's a N missing there. 102. All right. Setting up sniffing options. All right. Okay. Thank you all for coming. We're going to resume this Zoom class tomorrow at 9. I'm sorry, at 3 p.m. UTC. We'll test out our script, see how it works, and then we'll go on and crack. Tomorrow we'll work on WEP, WPA, and WPA2. And if we have time, we'll do WPS as well. Thanks for coming, and see you tomorrow. Bye.